Hi, welcome to Escape News Podcast. I'm your host, Ryan.
And I'm Chad.
And today we're going to be talking a little bit about space mining or asteroid mining and the Voyager missions. So I guess I'll kick it off with mine. Asteroid mining is one of those things where it was kind of science fiction-y kind of thing for a while. It wasn't very economically feasible. But with the advent of SpaceX proving that they can, dramatically reduce how much it costs to get stuff into and out of space, it's now kind of opened that window now to where there is actual business sense and a profitability that can be done with asteroid mining. And so,
is that because, are they actually saying that they have always known there's materials on asteroids that are worth getting, or that they recently discovered that there's materials that are worth getting?
Well, they've known that there are materials that are there that would be nice to have, but the economic feasibility of actually getting them back to Earth has just been out of reach, right? It was cost prohibitive. So they just decided, you know what? We'll shelve this idea. But now we're circling back around to it with SpaceX, like I said, driving down the cost of space missions. Now we have this incredible opportunity to actually start mining these asteroids. And a lot of it has kind of shifted to processing in space rather than just like shipping raw asteroid down to Earth, which has its problems. We're generally trying to avoid that. But we can now process a lot. We have a lot more methods and stuff, technology at our disposal, so that we can actually do that. So these have been some of the barriers that have been in place: processes, methods, and sustainability in space. And so the process is now kind of fleshed out as they've been kind of putting some different things together. So the first step in the process is to actually survey or analyze. It's a spectrograph analysis to kind of, what light was absorbed when we reflected things off of it, and the type of material that would be on there absorbs the different wavelengths. And so they kind of figure out, the composition of some of these asteroids. And there still needs to be some kind of prospecting that has to happen to really get a much better idea. But scientists have kind of put together different ways that they can, figure out what asteroids are potentially made of. And so there's been a couple of different things that have been proposed to actually capturing these asteroids. And the first way that they were actually looking at doing it, and I'll show you here in this picture, is it's kind of like a canister. It looks like a satellite with like a massive canister, and they can capture these. These are the smaller asteroids. If they're really big, they literally just lasso the thing and then taxi it back kind of closer to Earth where the processing infrastructure would be. And then once they get it actually within range, then so this next picture they're showing kind of like a cone that they put on it, and I'll kind of get a little more into that. So going back to once they actually capture the thing, this picture kind of shows them, encapsulating the asteroid. Once it's in there, they heat up the asteroid as they're taxiing it closer to their mining infrastructure or processing setup. They use solar energy to heat the whole thing up, which releases a lot of water and other gases from it. So that by the time they get there, they will be able to extract a lot of the water vapor from the asteroid itself. And this kind of helps with the sustainability of the mining colonies that they would be having that actually do a lot of this stuff. Plus, it makes it a little bit smaller. So once they actually get this thing taxied close, then what they put the cone on it, like I'm showing with this picture here, that's the cone is meant to kind of capture all the debris that's kind of made from all the mining operations and efforts. But the other thing they do is they'll start to spin. It's proposed they'll spin the asteroid and let centrifugal force pull the debris that's being loosened and broken up from the rock and throwing it up into the insides of the cone where they can then pick it up and process it. So it's actually pretty interesting. And then of course, once they have it all back there, they start going over some other methods, to actually getting the different materials out. So these asteroids come in about 3 different flavors. There's a C type, S type, and M type. C and S they compose a majority of the known asteroids, but the M types are the ones that are really looking to actually capture. So these M types are composed mostly of nickel and iron and cobalt, and they have some other trace elements in them. And when I say trace, I mean we're talking about a really massive scale, so trace actually means a lot. And so they have these different things that they have two main methods that have kind of surfaced that they intend to use. And fortunately for us, both of those are actually very well known processes and are actually currently being used in strip mining operations here on Earth. The first one is called the MOND process or the carbonyl process. It's a well-known process where they use a syngas or synthesis gas, which is hydrogen and carbon monoxide that just kind of carpet the outside of a surface, and it actually attaches and reacts with nickel. With nickel. And when it does that, it pulls it along with iron and cobalt, can pull that kind of stuff out, and then it kind of separates it. Well, then they heat up this now what's called carbonyl. They heat up the whole thing. And what ends up happening is the carbon monoxide kind of decomposes, and they can kind of recycle it. They can pull that carbon monoxide and use it for the next iteration. But what's left over is just pure nickel. So they can pull the nickel off using this MOND process, and then they have the iron, the cobalt left over too. That they can kind of do their own thing to kind of get that stuff off. And once they've done this like an iterative type thing, they've done it a couple times. At some point, the yield is no longer as good because what they have left over is not enough surface area where there's stuff to get the nickel out of. So then they just kind of dunk it into tanks of microorganisms that then further break it down. They do use this to some degree on Earth, where they just have these microorganisms just go to work on all the rock and they break it all down, and what they leave behind is what we're wanting to capture. So in terms of economics with this, just to give you an idea, so that they have identified an M-type asteroid right now where they believe there is a ridiculous amount of platinum, and it's still considered, I think, trace, but there's just so much, there's such a big rock. It's like 500 meters across or something like that, and it's, of course, it's long. So just to give you an idea, if we kind of go back and were to somehow measure the amount of platinum that we have ever extracted from Earth, it would fill an NBA basketball court about up to your waist. There is enough platinum in this one asteroid that could fill the court up to the rim 6 times. So basically, we process a single M-type asteroid, and we are able to extract more platinum in that one asteroid than we have ever extracted from Earth in as long as we've been doing it.
But I'm guessing the cost of like doing it on an asteroid is like considerably higher than doing it on Earth, like initially.
Yeah, and I think it has to do with transporting, right? There's no safe way of transporting a massive asteroid to Earth. I mean, it could be done, but I mean, I don't know. It's generally
just
not advised.
Up in the atmosphere.
Yeah. But they have, that's why they're trying to process this thing in space, and so the MOND process and the microorganisms are looking to do that. The microorganism thing is actually very difficult, I think, in a vacuum, and they had to probably create, obviously, some kind of facility where the vacuum is not present. So there's some of that stuff is really difficult, but they can still get a lot of this stuff just with the current methods that they have at their disposal. And if we even get a semi-fraction of some of the stuff out there, and we get it back to Earth, I mean, we're talking just, drastically driving down the prices for a lot of this stuff. Platinum is not cheap here on Earth because of its rarity. And the other trace amounts that we find in some of these M-type asteroids are ruthenium, rhodium, palladium, osmium, and iridium, which are used for I know palladium and platinum are used in car manufacturing. Iridium is used, I think Elon Musk is using iridium for some of his spacecraft he's trying to make. And so these are all very useful type things. Plus the amount of iron we'll be pulling off of this thing that's used in car manufacturing. Platinum is used for what are called autocatalysts, which pulls about 90% of the hydrocarbons and different kind of the nastier stuff that we have from exhaust. The catalytic converter is what it's used for. That presents a significant cost. We got electronics, medical components, fuel cells. All these different things are made possible because of platinum and some of these other materials. And so it's very much a profitable thing. I mean, a lot of money is going to be expended to actually get it to that point, but it's absolutely worth it. Just to give you an idea of the timeline, they're targeting, NASA has said 2025, they're looking to have analysis and prototyping kind of done. And then by 2035, they're looking for manned missions to these asteroids. And this would be where like actual prospecting would be done to actually get an idea of what we're dealing with and how best to taxi it back to Earth. or close to Earth. And then by 2045, they're hoping to have an actual, mining infrastructure in place to be processing this stuff. But I mean, the prototyping up until that point, we get one or two of these things, it will more than pay for itself and fund future endeavors to get us to that 2045 mark. So
that's interesting because like I read a thing about is the one that you're talking, is it called 16 Psych? Is that the one you were saying, or is that different?
It might be a different one. I do remember seeing something about that though when I was doing this research.
Yeah, I was just looking it up and it's like, these are really big. It will take a lot of time to get it here.
Yeah.
Or
but I mean, it can be done, right? They said it's definitely feasible.
Yeah, exactly.
So this is definitely something we want to do.
We could just get another moon, basically.
Yeah,
just mine it.
Yeah, some of the problems that they are thinking of is in terms of economics is driving these prices down so drastically. I mean, what's that going to do to world governments? I mean, there's a lot of third world countries that are already struggling, and their entire GDP is mining some of this stuff, and they're like,
but some of the materials that are like in these asteroids or that we struggle to get, even though that is the economy of some of these third world nations, maybe if we had an abundant supply of some of these highly valuable high tech materials, we could kind of raise the level of poverty globally because we can cheaply produce more materials or more high-tech solutions for people, I'm guessing.
Yeah, and
maybe a counterbalance.
And that's kind of a mid to long-term type solution, but that short-term is the real killer, that transition, right? So once we pull this stuff down, it drives the markets down for this kind of stuff. Everything's becoming extremely cheap with this massive supply. The prices are going to drive down, and so however long it takes the markets to react to that, those countries are going to suffer for those interim number of years, perhaps. I'm not an economist, so I don't know.
Yeah, we could just like fly those people up. Like what we do is like park the asteroid. Obviously, this is just ridiculous, but park it like hit the moon with it or something. Fly a bunch of people from third world countries that need jobs up there. And they can mine it up there, and then Amazon can just connect with this, and they can just drop ship from space completely made products from this.
That's a possibility. I mean, so they're looking at the part of the sustainability aspect is getting colonies of people living on these things. But of course, generating artificial gravity is another thing. I mean, they have some idea on how to do that by just spinning an inflatable donut around a cylindrical type living ship or something. It's really weird. There's a lot of stuff out there. I don't know how much of it is actually feasible, but it's good that there's ideas. And then just trying to figure out how best to make it happen. So hopefully Elon Musk will live for another 100 years. We can continue to leverage his brain to kind of figure some of this stuff out. He seems to be pretty good at it. So
it almost sounds like that show on Amazon Prime, The Expanse, which Sci-Fi had started. And if you watch any like shows about space and stuff, obviously there's content in everything nowadays, and so viewer discretion advised. But like if you watch any stuff about space, if you want it to have a real natural fear of what space really is like, you watch that show and there's the emptiness and what it would be like living on like some mining operation on an asteroid. It's just terrifying.
Yeah,
it's like I do not feel like I want to do that.
It'll take a special type of person to live up there, but I think it would help if they can make colonies large enough to support like a bunch of people. Like the International Space Station, I think is doable from like a mental standpoint because there's enough people there. If you were just by yourself, I think you go space crazy or whatever the term is for that.
Oh, so, really? Yeah.
Another good thing is that in 1967 they had signed the International Treaty of Outer Space, which basically made no nation on Earth is able to just simply claim land outside of Earth. So that was another concern people had, but it was apparently already solved. Solved in the fact that no one's going to sit there and claim stuff. Like you find it, you get it. So that kind of...
Oh, really?
Yeah.
So, like, they're not allowed to claim land under, like, just in general, like, kind of like how we do with Antarctica without placing stuff there?
Right. Yeah, so, like, I mean, we've gone to the moon and put a flag on there, but, like, the United States, as far as I know, can't just say, this is ours, kind of thing. It's...
We have Mars.
Yeah, right. So some nations are like, I'm pointing at it, therefore it's mine. It's like, well, no. Apparently everyone signed a treaty that says that that's not going to happen, so...
So, like, you have to actually, like, have assets on a space body to, like, claim ownership of it, like people and machinery and stuff?
Yeah, as far as I know, and I don't know how that works. Like, like, do you have to have machinery on top of the land that then becomes yours, and then it's freed up when you leave? Like, you don't get to own it in perpetuity. I'm not. That's where, like, that's something for lawyers to kind of figure out. Space lawyers. So that is going to be a new, I hope, futuristic career. I'm only joking. I don't know if there's such thing as space lawyers. It just sounds really good and cool. I might.
From what I'm reading, though, it says like the Space Treaty of 1967, which is law, clearly states that the moon and other celestial bodies are the heritage of all mankind for the purposes of exploration. So apparently, you can't even claim it for anything.
Awesome. So, but I have some claim to the moon, being a human.
But then the U.S. Space Force says otherwise once they get there.
yeah. The person with the guns is the one who owns it. So, well, yeah, who knows? Exactly. But yeah, it's pretty interesting. This is definitely the way to go. I mean, like, if we as a human race were looking to explore our solar system or even go beyond, we're not going to get there by sitting on Earth and trying to produce things here. Space mining or asteroid mining is where it has to be, right? And NASA has talked about that too, creating shipyards that build the craft that will take us to other planets. There's a lot that goes into getting a craft off of Earth and into orbit, and it requires a completely different configuration, a different design in order to actually traverse space. And so, you can't. It's hard to kind of design both. So, like, we're just going to have one craft that gets you off of Earth and into orbit, and then from there we would have a shipyard and colonies, and you would then get on a completely differently designed spacecraft. One that's like, obviously, this thing is not going to fly. It's like, it's just some big bulky thing. It's not meant to fly in atmosphere. It's meant to, convey people through space. And then, of course, that goes into a whole other thing about, the attempts to get faster than light travel and that kind of stuff. So,
yeah, which, I mean, that makes sense when you're like looking at space, because a lot of people, I think, miss the point. They don't understand why rockets like go so horizontal rather than vertical when they start flying, because the distance from where we are on Earth to space itself is a very short distance, but it's the speed that you really have to match that horizontal speed that space is, like the escape velocity and all that stuff. So it's less of like a force of going up than it is like matching and going out. And so obviously that requires a different vehicle than just, going from the moon to Mars or something like that. So obviously Mars doesn't have like its own gravity fields to the effect that we do. So it's a whole nother, system of working with.
Yeah. But it's exciting. This is definitely something that we potentially might see in our lifetime. And the benefits from it are could potentially be very, very nice. And raising the overall quality of life for a lot of people on Earth is pretty good. And as we've seen with the space programs of the past, I mean, we have gotten a lot of stuff, a lot of great technology just from trying to get ourselves to the moon. So like NASA has like what NASA all did. There's like a lot of technology spun off of that space program that we enjoy today because of that effort to get to the moon. So who knows what,
like Velcro,
yeah. I think microwaves,
plastics in general.
Yeah. So it's interesting, a lot of stuff. So I'm excited.
Yeah. Yeah, I mean, that is really exciting. So, which, I mean, at the end, we're going to have to talk about some conspiracy theories. But
yes. Like what's on the dark side of the moon, Illuminati, origins of human life on Mars, that kind of stuff. Like, Earth,
the lizard
people.
And stuff like that.
Yeah, Earth was a diaspora of people originally made on Mars. It's crazy stuff. I can't wait.
Oh, no, like the good ones are about what's going on currently on the moon. But we'll get to that in a second. I want to talk about the Voyager spacecraft. And so just because we've heard about them recently in the news and just what's going on and as they approach end of life, because that's in the next couple of years. And we have to remember that like this has been about 77? What year is it? It's 20? Yeah, it's like, so we're like 42, 43 years of life that these pieces of these machines that we built decades ago are still sending and receiving signals, which is, the old phrase, like they don't make them like they used to. They can build this thing that's going to last 40 years, but my microwave can't last like a year. So
Planned obsolescence.
I don't know what's up with this.
Another conspiracy theory. It may not be conspiracy.
Yeah, exactly. We'll have to get into that another day. So going back to these things, the reason why these were launched, and obviously like they wanted to do space exploration and stuff, that's the primary reason. But the reason why they were launched when they were in the late 70s is, this is what I wrote earlier, is the Voyager launches were preceded by the realization that a unique alignment of the planets would allow for observation of several planets for a spacecraft that would sorry, I messed something up. It's a unique alignment of the planets that allow the spacecraft to observe several planets on its way out of the solar system, which basically when they figured this out, I can't remember the guy, I should have looked up, but the scientists who figured this out, then they were like, oh, hey, we have a window of time and we need to launch some vehicles out there quickly so we can take pictures of all these planets as they head out of the solar system. And so they prepared Voyager 1 and Voyager 2, and uniquely, Voyager 2 was actually launched first, but Voyager's 1 trajectory and being faster, it actually reached the first two planets of Jupiter and Saturn before Voyager 2. So that was pretty interesting. So this was in 1977, August 20th, Voyager 2 launched. Voyager 1 was on September 5th, so just about a month later, or actually not a month, just a little bit of time later, but some information they were delivered to space aboard Titan Centaur expendable rockets. And obviously, if you get into technology with rockets, we're using something different nowadays, especially with Elon Musk doing all he's doing with the rockets that return and stuff. So these were originally called the Mariner, Jupiter, and Saturn missions, but they renamed it to Voyager because of reasons unbeknownst to myself. And I think it was mostly because like they're going on a long journey and they're going further. They just decided. So quick recap of what they did. They launched them, and then Voyager 1 spun by Jupiter, and then it hit Saturn, and then it straight out the solar system. And obviously it's not like straight out the solar system. That's like recently it left our solar system. It took a long time, obviously. But your Voyager 2 passed Jupiter and then Saturn and Uranus and Neptune. And all these things, like, it's amazing. The on-board camera that was taking pictures while they were approaching Jupiter, we had some amazing photography and time lapses of the storms on Jupiter's surface. Obviously, you know, that like big storm eye. That was really cool. And some of the rings on Saturn, we got to see more of the rings on Uranus and with Neptune and stuff like that. We get to explore these. And actually, they recently, I say recently, but it's like more than a decade ago, they revisited some of the documentation that they had on Uranus when Voyager 2 passed by it, and they realized that it had expelled like this large emission of gas that I was reading about. So they learned some new things about Uranus and how its chemical composition, how that all works, and then also got to take some cool pictures of the moons around that planet. And uniquely, those are named after characters from Shakespeare's stories. So I thought that was pretty cool. A little bit of information
on Jupiter. I remember there was one of the discoveries was the hexagonal storms at the poles. Wasn't like I thought that was really interesting. Like how that even forms that way. I didn't catch. I think someone explained it, or I'd read how they had them explaining it. I didn't quite understand it, but that to me was really cool. Seeing a massive, at the poles, seeing this massive hexagon-shaped storm that would completely eclipse the Earth inside of it. It's just incredible, the forces at work there.
It's very scary, like, because the same thing that they found on Uranus was a storm that, and that planet was weird. Its rotation and its rings all rotated in a bizarre like pattern. Well, not in pattern, like they can't map it correctly because it's just really weird. But it had a storm that also followed like a particular point on the magnetic field around the planet. And these storms, when you're coming to these planets, like especially Jupiter, like huge. Just, I mean, whew. Which obviously I don't know how close we've actually gotten to Jupiter, but I know that like the compression and the forces of the gas and because of its mass and whatever, like when you get up to it, it's somewhat destructive.
Yeah, I think they sent something down into it and it didn't survive re-entry. I honestly like some of the stuff they've actually tried doing. Was it Cassini? I don't remember, but like some of the stuff they know they've tried doing to try and like look and see what was going on in some of these planets. It's been interesting. I get them all kind of confused. And I'm not really sure how much information we got from it, but I mean, it's really cool to kind of read when they do stuff like that, though.
Yeah, exactly. So then they actually turned off. So it was about 1989 that they turned off Voyager 2's camera because it's never gonna get close to an astronomical object to like take pictures of anymore. But they have other devices on there. So what they do with these Voyagers now is they do maneuvers and they like pivot them and turn things off and take data with other like the remaining devices. I think it was about 5 devices roughly on each Voyager now that are left to take data mostly about like gases and things like that. I'll get to that in a second. And then right after they turn cameras off on that, the pale blue dot is the image that Voyager 1 takes. The last images, like you can see like the little Earth way off in the distance. And then the big thing was in 2004, Voyager 1 crosses the shock. And then shortly after that, I think it was, 2007, Voyager 2 crosses the shock. So what you have like with our solar system, you have this, because of our sun, you have this magnetic field. And they learned a ton of stuff about what happens outside of our solar system because we thought that the magnetic field would suddenly change when they got outside of our heliosheath and heliopause, and it's all complicated design stuff, but like when our solar system is moving through our galaxy, there's magnetic forces at play, and there's also plasma and things outside of it that this heliosheath and heliopause that they call it are protecting us basically from. Then outside of that, I'll have a picture video here. I'll have this on screen. Like you have our solar system in the center, and then you have a picture of the Voyagers like leaving, and they're about to enter or go through the heliosheath, which is like this big open, I don't know, like it's almost like a bullet, I guess. Like to me, I picture it that way. Like you have the actual object traveling, and then you have on the surface of it like that initial buildup of material that's kind of like, I don't know, in a way like protecting it from the outside forces of the actual air or whatever it's traveling through. And that's kind of like how we're moving. And once the Voyagers actually crossed outside of that into more of like the plasma areas. Let's get here. Where is it? They enter interstellar space is Voyager 1 is the first one, and then Voyager 2 enters it, and we learned that the density of the plasma out there is just way higher. It was 40 times higher than previously measured, and also the temperature was incredibly high, and we learned that this heliosheath and heliopause area is really protecting our whole solar system from this outside stuff as we're going through our galaxy. And that the interesting thing was also that like the radio frequencies or the magnetic frequencies that were moving inside of our solar system are actually similar in the way that they align themselves outside of it. So there was no change that they had predicted, that there would be like this big change with radio magnetic frequencies. So that was interesting. We learned a lot of things about like, oh, how does the universe actually work? But now we're approaching end of life, so it's only a few more years. They have plutonium nuclear reactors on board, and they expect by 2025 that these things will be dead. And the big thing in the news was we just reestablished contact with, I believe, Voyager 2. So what happened, Voyager 2 had was kind of a troublemaker. It had some issue at some point. We told it to make it a maneuver so it could shut off some devices, and then it failed for some reason. But we also had to shut off communications with them because of where they're at in relation to Earth. That there's only one, I forget the name for it. It's in Australia. It's the big telescope communications array. They had to do repairs to it, and it's the only one that can actually communicate with the Voyagers because they're on that part, like they're southern hemisphere objects now. So nothing in the northern hemisphere can do anything to communicate and tell them what to do, though we can receive signals from them throughout the world. We just can't tell them what to do, except for from that point in Australia. So they finalized those repairs, and they reestablished contact, and everything's fine. We're learning information. They're sending back stuff all the time, but any communication that we have where we send them send the Voyagers a command and then it returns, it takes about 34 hours right now. And obviously that time will continue to take longer. But it'll be interesting to see what happens because, like, I mean, I don't expect us to ever get to the point where we're gonna like go and recover these objects. And we also did like make these gold plaques with
Yeah.
our like here's our Earth in relation to the universe and or our solar system and how to find humans and some stuff about us and here's some music and whatever. So it'll be interesting. Like if there were aliens, I'm not a believer in aliens, and but if there were and they found it, I mean, what would they think?
Yeah, Stephen Hawking, before he passed, he had talked a little bit about life outside of Earth, and he said it most likely is not something we want to discover. More importantly, we don't want to be discovered by life outside because we have no idea. You and I walking on a sidewalk, we see some ants, going about their business. We don't really think much about it, and that would be great for us if we're the ants. But someone could just come by and it's like, well, we're going to build a sidewalk here, and so we're just going to dig up your entire anthill and toss it. So we don't want to be discovered. It's nice that we have this anonymity because we don't want to be discovered. But that's kind of his thing. And again, I don't really believe aliens exist either. There's even a couple. I wish I could remember it. Fermat's postulate about it, like we should have found life by now, kind of thing. Like given the vastness of the universe, of the observable universe, or what we can even see within our own Milky Way, and you going through the statistics of us, being here, we should have found something by now. So it's all some people believe different things. So I don't know. I think the whole thing is terribly interesting. I mean, I'm all about even if whether or not you believe it exists, like we should totally pursue it because it's just fun and interesting to do. So.
Oh yeah, it's definitely fun. It increases like our level of technology, trying to push ourselves beyond what we're currently capable of. And going back to the alien thing, like I would think that if there were aliens out there that had some vastly greater or more superior technology, they would know we're here because we send so much garbage out into space constantly. Not like physical objects. Well, I mean, we're sending physical garbage out into space too, but like are so many radio signals, and it would be hard to think that like because of the way laws of physics work and stuff, it's not like they're going to develop some other technology that doesn't know what radio signals are. I can't imagine that would be the case. And so they'd pick us up. Obviously it takes some time, so if there was something, it'd have to be well outside of our distance of we've been sending signals for what, like 100 years now or something like that. Maybe not 100 years. I don't know exactly what our telecommunications were 100 years ago and whether or not those pierced our own ionosphere and all that and escaped into space, but
yeah. Well, I'd read something else. I'd read something about the fact that we haven't found anything else could be a little kind of haunting, in that because some people believe about the Great Filter, so there may have been other civilizations, right? That they're just thinking there are aliens out there, or there were, and they hit the Great Filter and didn't make it through. And so then for us, does that mean have we hit the Great Filter and passed it, or is that yet to come? The reason why you don't find life out there because it's already gone. They had their chance, and for whatever reason they didn't make it. And so, are we going to make it? So there's a lot of philosophy around it, which is pretty interesting to kind of think about and talk about. But yeah.
But going back to our Earth and conspiracy theories here, I came across the most unusual things that people believe. I mean, obviously, whenever you people believe like the moon landing was a hoax and all that stuff, but there are these lights on the moon, like sparkly points that are just undeniable. Like, hey, there's something shiny on the moon, and what they are is kind of unknown. But I don't know, people that wear tinfoil hats or whatever these people are, I don't know. They are saying that those things, in light of over the past decades, like several countries have suddenly said, for no reason, just like, oh, hey, we're going to the moon. Oh, hey, we're like going to Mars. Like, oh, we're going to start mining on the moon. And a bunch of countries just stepped up and said, hey, we're going to do this. And they haven't even done anything like that before. Like, they've been trying to get to space, or they've been interested in space programs. But suddenly there was this quick resurgence of, oh, hey, we need to like go there right now. And it kind of, these people put two and two together in their minds and said, oh, something's going on, and like there's actually something up there, or they're like this other force. Kind of like, did I explain the Antarctica theory to you?
You touched on it in a previous episode, I believe. We didn't really go into it.
Yeah, the gist of that was with like Argus, which is where we were like testing nuclear bombs down in Antarctica. The idea was that we were like testing building radioactive like barriers to prevent like bombs from hitting us and communication and stuff like that. But people thought it was very curious when the U.S. sent down a group of, I think it was 4,000 soldiers down to Antarctica to do training, and a bunch of them died. And then we go back, like, I can't remember, a couple months or a year or something like that, with 3 nuclear bombs, blow them up, and then burn all our documents on it and leave. And so they think that there was like some advanced force down there that we found, got scared, and came back with everything we had, bombed them, and then just like left and just buried that whole information. But I mean, I doubt that that was the case, but there's actual evidence, and more recently, Russia found a Nazi base. There are like Nazi bases just hidden all over the world, apparently, but like they
Argentina.
have Nazi bases. Yeah, like they have Nazi bases in Antarctica, and some that apparently we haven't even discovered yet. And some people speculate that like there were a bunch of Nazi leaders who had advanced technology, and when their regime was collapsing, they took all their stuff and moved down to Antarctica, and then America encountered them years later and said, whoa, we got to wipe these people out, and just buried that information, bombed them, and then left. Because it's really hard to like find any information regarding it, which means you develop conspiracy theories. So I think that's what they're leading to with this moon thing, like maybe there are Nazis on the moon, which I haven't actually heard that. Maybe I should start that one. That'd be kind of fun, you know. There's Nazis on the moon, and that's why everybody's
I'd play that game.
Yeah, we could go spread this one around. It'd be really fun. Nazis on the moon, America, and everybody's going to war. Oh man, that'd be weird. But I think that was the only like new, obviously like Elon Musk and everything going on with Mars. You have other conspiracy theories that like relate to human life starting on Mars. And when you look at the information, I mean, it's really interesting to think that Mars looks like a planet that was habitable and something hit it and wiped everything out. It almost looks like that way, that like humans or something could have been on Mars and we left and came here and restarted. Obviously, I don't believe any of that, and I don't agree with any of it, but like it looks almost like that when the data is presented in like a certain light.
Yeah. Yeah, I think I read it because they were seeing like water channels on Mars. Like, well, there must have been something there, and they did show that like basically the sun, solar winds just blasted the atmosphere off of Mars, and which could have then evaporated whatever water was there, and whatever's preserved is in ice caps and or like deep underground. So a lot of that speculation. I mean, some of it's kind of speculation, but they're actually trying to figure out like, well, for manned missions to Mars, they're kind of banking on some of that being the case, because if there's underground water channels that are completely empty, then underground water channels that are now empty are great places to put a base that protects you from the elements in Mars. And so they're kind of looking at, what happened to Mars, what terraformed it the way it is now, and how can we use that to our advantage to put a colony on there or put some kind of forward base on there when we get there. And so it's that's pretty cool. A lot of it's like the lines between science fiction and reality are certainly blurry, and it's absolutely exciting. So
I know. I mean, that's where a lot of the stuff we come up with ideas, and not necessarily that somebody like watched Star Trek and then went and made the cell phone, but they had stuff in Star Trek that was like, wow, that's like a lot like their little telecommunicator flip-over device, and we made that years later. And there are a lot of things like that. Like if you go look at Stand on Zanzibar, or you read any of those other gold and silver age sci-fi authors and see the world that we live in now, you're like, whoa, not that they predicted this stuff, but they really knew like what could be, and surprisingly got things
Isaac Asimov had a lot of really cool ideas too. He had a pretty good mind for that, like pulling to cross-disciplinary ideas and that kind of stuff. So I'm kind of excited about moon Nazis, though. That would definitely motivate a new generation to explore space and defend it from moon Nazis.
Yep. Well, you've heard it here first. That. Everybody go out and hashtag moon Nazis. We're hashtag moon Nazis campaign all over Twitter, whatever you can find. We're gonna go find those Nazis and get rid of them. Yeah, I know.
I can't wait.
Oh no, it's annoying because like Nazis and stuff like that is becoming like popular again in America. And,
they're always a popular villain, like Wolfenstein.
Not
game
like as a popular villain, but like people are like actually like Nazis nowadays, and I'm like, no, like
that's true.
But I don't know. People are crazy.
Making a resurgence.
I know.
Yeah. Oh, yeah.
Well, we're going to have to start that campaign, Moon Nazis. You're going to see it. I'm going to get out.
I can't
There'll
wait.
be a link in the description with our store and our logo on merch, and I'm going to get a Moon Nazis merchandise out there. We're going to the moon.
I can't wait to get the shirt.
Defeat the Nazis.
Going to the moon to punch a Nazi. I can't wait.
Okay, and we'll advertise it in next week's episode. It'll definitely be in the link in the description, though. This is going to be great. Well, I don't have anything else to share. I think I'm all done at this point.
Yeah, I am too.
All right, well,
we covered it all. Moon Nazis.
You heard it here first. Moon Nazis, hashtag it up, and connect with us. Like, subscribe on YouTube, comment. Of course, we love to have a discussion. You can check out our links in the description for merchandise with Moon Nazis, Patreon, support the show, and of course, if you're on podcast, leave a 5-star review, and we'd greatly appreciate it. So, well, this is me signing off. Thanks for joining Escape News Podcast. I'm your host and co-host, Chad.
I'm your host, Ryan. Thanks for joining us.
We'll see you guys next time.